So I'll introduce you now, and we'll get started.
Okay, perfect.
Hello, everyone. Thank you for joining DataCon LA 2020, and welcome to the Data Engineering track. And soon we'll be listening to Enabling Data-Centric Teams session with Nawar Kabaz. I am Eli, your host, and our co-host today is Stephen. We will be moderating the chat and Q&A for you during this session. Today, we have our guest Nawar Kabaz, and he will be talking about enabling data-centric teams. Nawar is a data engineer with extensive background in Python, SQL, cloud architecture. Looking forward to mix his analytical, technical and management skills in various scenarios to improve efficiency and productivity. Nawar has around a decade of professional experience, started in product engineering. His data engineering expertise has saved companies like Qualcomm, Broadcom, Sotera, Wireless, and a huge amount of capital and time, leveraging efficient architecture and cutting-edge technologies. Without further ado, I'll hand this over to the speaker. Thank you for being here, Nawar.
Thank you, Eli, and I'm honestly so excited to join DataCon LA, even though it's virtually this year, but I think DataCon LA has really shaped my career the way it is in the past years, and listening to all the and also in this year, listening to all these talented people around and listening and absorbing all the projects that everyone's working in, and a lot of the new technologies and open source stuff, and even like paid stuff. So you get to know the feel of the market, especially in the data field. So I'd like to thank you and thank Subhash for organizing DataCon LA for the past years and this year and many more years to come. So to start, I'll be talking today about enabling data-centric teams, and I would like to introduce myself as well. My name is Nawar Kabaz. I currently work in the data engineering team. I work as a battery data engineer at Rivian Automotive, and just a brief review on Rivian Automotive. We're planning to manufacture electric trucks and SUVs, and we actually debuted it a couple of years ago in the LA Auto Show. We had a couple of prototype vehicles, and hopefully this year we'll come up with our models. So look out in the market, and we're also going to be manufacturing the Amazon Prime vehicles. So in terms of electrification, Amazon is heavily invested in this. So we're leading that effort currently. So a bit of a background about me. I started my career as a product engineer at Broadcom, and then moved to Qualcomm in basically the SoC and the silicon product engineering, and then I shifted towards the health sciences and worked as a lead data engineer at Sotera Wireless in San Diego, and currently I've been working at Rivian in Irvine for the past year, and I've been involved in a lot of open source data and a lot of organizations around data, if it's connecting social sciences with data and doing data for good. And I've been trying to get involved with Subhash LA Data for Good and all these stuff. So it's been good. So and a bit of my technical background. My technical background is in electrical engineering, but as a product engineer, you're kind of forced to work with massive amounts of data, and time is usually the essence. So you're always trying to figure out better ways to analyze your data, to visualize it, to digest your data and ingest it properly, to have it consumed by our teams and the rest of the teams. So uh, so basically, I was kind of grown into the data engineering job by necessity, which I think this is where you learn the most, where I was basically learning about every technology to save us time in analysis and procurement of the data and visualizing the data to other teams and ourselves. So I had to wrangle around the data so much so that I can understand what's going on. So in that path, I learned that the data engineer's job is to help the company or the organization to achieve its goals by enabling the data-driven analytics and trends by combining all the domain expertise with the latest analytical models and have top-notch analytical software architectural skills, all of that combined. So TLDR, there is no such human, because if you have the top-notch domain expertise, you probably don't have the top-notch analytical and software and architectural skills. So uh, there is a lot of times where there is a disconnect, and I'm pretty sure everyone has been through this, where, for example, if you're in the engineering teams and you're trying to visualize a model or trying to build an analytical model, there will be a definite disconnect between you and between the software engineering teams. And this disconnect comes because the software engineering teams are usually not domain experts, but they're tasked to build the analytical models, and vice versa. You as an engineer in, let's say, in a hardware domain, you don't know much about the software architecture and the analytical baseline to figure out a model. So so basically, what everyone tries to do is to do as much as possible where the software engineer learns about the domain. And this is usually hard because there's a lot of, as you know, in, let's say, in hardware software, there's a lot of subdomains and there's a lot of things to learn. And you're like pretty much don't know where to start. So basically, the bottom line is to bridge the gap between domain experts and having and building analytical models on their own. And we're going to talk about this and how to bridge the gap in between. So how is that doable? By data enablement. So as the number one rule for the data engineering in any organization is not to have a gatekeeper for the data, and to have the data accessible to everyone so that you'll gain the expertise of all the domain experts to model your data so that it makes it easier for you as a data engineer. So so as we all know, that old saying, give a man a fish and you feed him for the day, teach a man how to fish and you feed him for a lifetime. So this applies to the process of enabling the team and domain experts to the data access and enable them to model their data at their own freedom. So what that means is you basically enable the domain expert to have modeling and analytical type of skills, which I know it could sound much to learn, but at this day and age, we have all the tools in our possession to enable that. And I've had success at all of my previous workplaces and my current workplace, where I would enable domain experts that come from non-software engineering background to do at least some analysis and some modeling and some visualization, so that I will take their models and scale it at large and put it in a production architecture and whatnot. And as I talked about the data engineering philosophy, I think in a lot of the monolith companies and like the older architectures, there's usually something called the dragon approach, where you have one person or one entity act as the data gatekeeper, and everyone in that organization has to go to that data gatekeeper to in order to get the data or to even get any meaningful insights out of the data. So this usually have like in such architecture, you'll have like more of a tunnel vision. You don't know, there's like a longer process to innovate, and there is a lot of disconnect between the domain experts and between uh, what's happening as far as the data analysis and modeling. So it's usually comes with low productivity because of that disconnect between everyone and the data entities, and high maintenance, high burnout costs, low visibility on analytics from the organization. So for example, in order to visualize a model or analyze a model, you'll have to go through so many hoops to get to production and deploy your models. So there's another approach where there's a lot of companies are adopting right now, and even the monolith companies are adopting some sort of a decentralized approach, where the decentralized approach, where you have the data pipeline and operations are accessible by everyone in your organization, and all domain experts are essentially working in parallel to model and drive analytics. And what I mean by that is you'll have domain experts that depend on a certain type of raw data that you need to provide to them, and you need to, let's say, provide access for. But you have another domain expert that needs more sort of analyzed data and whatnot. So in enabling those people to gain access to this data and to model on their own, you essentially in let's say in parallel computing terms, you have parallel workers in your own organization, and by the parallel workers, you'll have people to model their own stuff, and then you could take it as a data engineer at the end and deploy it in parallel and deploy it to production. So a lot of people ask, what is like, how do you decentralize an architecture, a data architecture per se? And one of the main hurdles that I've seen around domain experts is that, oh, like for example, I don't want to learn a new scripting language, or I don't want to get myself involved in something that I don't know anything about. And they see like there's a large enablement phase to that, which I do see that, and I do know that it's somewhat a large enablement gap. So I started deploying and adopting the Jupyter framework, which is, I think, as everyone knows, and if you're not familiar with it, Jupyter is basically a collective framework where you could deploy IPython notebooks, and it makes it, I think it makes it easier for everyone to collaborate and to visualize and to do whatever they want with their own data. And then you could deploy your data to your models to production. And the other thing that I've seen that is very useful in big or medium-sized organizations is the cloud-based data lakes. When you have everything in, let's say, cloud or even on-prem, if you have the ability to support that. But when you have data lakes that contains your essential raw data and your production data, then you are more able to open this data lake to everyone in your organization and have more democratized data situation where everyone can actually see your raw data and everyone can actually model their stuff based on the raw data and whatnot. And then, of course, you need to think of the situations where what happens to your analyzed data. Do you put it in a database or do you put it in a like non-structured form back to the data lake and all these stuff? And this is, I think, case dependent based on your type of work and based on your type of analysis at your organization. But the most important thing is, I think, the visualization framework. And with the visualization framework is that you'll enable everyone in your company to drive insights out of your data and make it as easy as possible to access this so that even, let's say, people from sales or marketing or people from quality control can access this easily and can tinker around and figure out a visualization model that you could deploy yourself in the production. And of course, the ETL pipeline with an asterisk, this could depend more or less on your organization. So another successful approach that I've taken in the deployment and enablement of data access for people is the Jupyter framework, especially when it runs on a cloud compute instance, because of the high scalability and the higher performance. And honestly, at bigger sized companies, for example, like Qualcomm, when we switch towards high scalability and high performing Jupyter framework, we even noticed a reduction in and cost saving in people's own computers, because at this point, if you're running your analysis and whatever visualization you're running on a cloud computer instance, you don't need a powerful personal computer. And that's one of the extra pluses that we gained when we enabled it. And the other thing that people should think about as data engineers and as domain experts is the collaboration across team members, regardless of the technical and coding expertise. So the collaboration happens in that framework where you could essentially work under one server, and there's a shared area where you could see other people's notebooks and you could tinker around and you could figure out what other people are doing and how to do other stuff and whatnot. And I think I can do a quick demo on the Jupyter instance that I have. So I'm viewing currently my personal Jupyter instance, and with Jupyter, you can essentially present your data as is. So you can present your code, and you could present whatever you get out of your code in your next meeting or whatnot. So you could do whatever you want type of analysis, and you could present it as is. So for example, these are all sample notebooks for data visualization and using multiple libraries as you know, like Plotly, Seaborn, and all these stuff. So it's very useful to use and very convenient for the non-domain experts, especially. And one other thing that is very useful in Jupyter, since it's a very high scalable server, you could essentially run apps like Plotly, Dash, and all these stuff. I personally use Dash because of the because of how easy it is to use and how connected it is to your data sources. And it could basically bridge that gap in between domain experts and non-domain experts if you want. So as you can see, I can.
Sorry to interrupt. If you want 10 minutes for questions, there's 10 minutes left in your presentation.
Okay, sure. So we can open it for questions since we're about to be done.
Oh, well, you've got 10 more minutes before then if you want.
Okay. So I'm just going to be showing an example of the dash type of. So currently I'm deploying a visualization model on my Jupyter server, and then you could easily, this is an example from Plotly where you could see all sorts of the visualizations that you could do, and you could enable other teams to access and even modify. And usually your model basically runs on a Jupyter notebook, and you could even visualize it without the without going to like deep in the code, and it's usually annotated like this. So I think from this approach, I've gained a lot of domain experts that don't have much to do with, let's say, scripting and coding and modeling. I've gained them into this realm to be able to do their own stuff and their own analysis. And I would say majority of the time their analysis are spot on, so I would deploy it to production. But at that point, it's super easy for me because someone already built a model, someone already built a notebook that I can import to my production. So I think I would like to finalize by saying usually, but for data engineering, the best approach is that you open your pipeline as much as possible. You enable everyone to access the data, because you cannot be a domain expert and the domain expert cannot be you. So you kind of have to bridge the gap and enable the domain expert to model and analyze, and then you take it and scale it for production. So I think now we could take questions from the attendants.
So there are two questions. Do you want to read them, or do you want me to read them off to you?
Sure, you can go ahead and read them.
Okay, so the first is, thanks for your talk. How can one break silos across teams to make the organization increasingly data-centric?
So that's a very good question, and I wish there was a simple short answer to that, but there isn't usually. So I think one of the healthiest approaches to enable the organization as a whole, and especially if it's a big organization, is that the data knowledge. So you should let people aware of the type of data and type of analysis that you have, and then enable them. And by the enablement, I mean that you could have a way where you could break into your silo, break into your data lake, and enable that team to access this sort of data. And this is usually, at this day and age, it's very easy to do, especially if you're working with a cloud data lake, the likes of AWS and G Cloud and all these stuff. You could have as much as specification and customization to who access what and how, and what is the frequency of the data they need to access, and all these stuff. Sorry, Eli, I think you're on mute.
I do that so I don't take up your screen real estate. Let's see. So the next question is, what are some project ideas for practicing the decentralization approach?
So honestly, if you're for some project ideas, is that you could work on stuff like for example, Dash by Plotly. They have like a huge visualization library that you could work with your friends, with your colleagues, with whoever you want, or even for yourself, where you centralize. Let's say you have this visualization app that you're trying to build, and you have a common data source with you and your friend or colleague or whatever, and then work on that model collaboratively. So you'll have it somewhere in a GitHub repo and just work around, and you could have each your own branch, and you could do that. So in terms of hobbyists, and in terms of professional, like workspace type of thing, is that I honestly think if you could deploy some sort of like a GCollab or JupyterHub or something, so that if your data customer needs some sort of data, you could give them a Jupyter notebook that they can always read queries from your database table, or they could always read from your S3 buckets or whatever buckets. So I think you could experiment little by little by just deploying something like Google Colab or Jupyter Lab, and then start little by little and see how people absorb that. But most likely people will be very welcoming and very absorbful of such ideas, because even the domain experts, everyone nowadays have some sort of scripting expertise, either in Python or R or some sort of thing, so they could start tinkering around.
The next question is, thanks for the talk. Seems like a lot of data or information is flowing between participants and collaborators. What kind of effort is involved in maintaining and validating, I guess, the data? Thank you.
So that's a very good question. And in terms of the data validation and let's say testing the data and what goes into where, and what happens to what data, this is mainly where I put the asterisk on the ETL pipeline, because with the ETL, you due to whatever your company is working on and whatever type of data, you need to do some massaging for the data. You need to extract the data in a way so that it enables someone from, let's say, hardware engineering to be able to access your data. Because, for example, if you have it in a Hadoop cluster and you tell someone from the hardware engineering team, hey, can you access my Hadoop cluster? This is where I have my data on. This is not going to work, because you're increasing the enablement phase for that person. That person needs to be so involved and so knowledgeable and knows what a Hadoop cluster and how to access it in order to do that. So what you need to do as a data engineer who's interested in decentralizing is to make even your raw data somewhat accessible to people. And honestly, depending on the size and structure of the data, you could put it even in CSVs and put it in a data lake, because a lot of the data lakes nowadays enable indexing on CSVs, and you could query CSVs without building anything on top of it. Or you could even do Parquet, and Parquet is relatively easy to retrieve and write and do all these operations with. So I think this is where it comes, where you decrease the enablement phase for the other people in your organization. So you need to make it as easy as possible for them to retrieve the data and work on whatever they want.
We have another question. Have you ever witnessed an organization have resistance to transitioning from a dragon approach to a more democratized approach? Any war stories to share or lessons learned?
Definitely. That's been the highlight of my life, basically, where you're, because in especially in a monolith or a megalith type of company, there is very defined structure and very defined flow to the data flows, let's say. And what I've witnessed is that it hinders innovation, it hinders a lot of the analysis that needs to be done, let's say, by domain experts. But it will maintain your production as is, because this is a very robust type of approach where you have one data pipeline that's flowing and no one can disturb or no one can do anything to it. And usually what I've been successful with is to identify uh, how change will help us and definitely save us two things: time and money. If you want to pitch it for your management, talk about saving money, and this is going to get you all ears in management. And if you want to talk about saving time, talk to engineering, because this will be the highlight of the thing. So you always have to find, why do we need to do this, and explain clearly and plainly on why do we want to do this. So for example, my first big migration from on-prem monolith to a cloud architecture that is decentralized happened when I simply pitched to management that, hey, by the way, if we have more data access, we can build analysis tools, and you wouldn't need that SaaS program that you're using, which costs $600 per license per person. So they did the math, and in a 600 people organization, that was like, I think, $75,000 saved if we go on open source, but we need to decentralize our data. So always talk in terms of either money or time, and this will pave the way towards that resistance.
Wait a minute and see if there are any more questions. I'll ask a question. So from your experience, the decentralized approach sounds like it makes more sense in a modern architecture of a business.
Very much, because yeah. Because as I told you, I always use this example. So I in like a lot of the consultancies that I've done and in a lot of my work, what I tell them is that think of it as the issue of running, let's say, running code on your personal computer that has like 4 cores, versus you have multiple parallel workers that are doing multiple threads. So it's a single thread versus multi-thread. If you have a centralized data approach, that's essentially a powerful single thread, which is only as efficient as possible. But if you have multiple threads, which are the multiple people that are working in parallel to achieve, each is achieving their own goal, and then you could combine in production, I think this is the most efficient approach. And usually the way to do that is to show people how easy it is to get started. You know, once they get started and once they tinker around in models and access the data and what to do with the data and how to visualize it and share it, and then it will make your life much easier. It will drive efficiency way up, and you will see the fruits in very immediate future. So that's basically how I preach this. It's always think of it as single-threaded versus multi-threaded type of approach.
It's a very good metaphor for,
yeah.
for working in this way.
It's only right to mention this metaphor in DataCon, you know.
Right.
Sorry, Eli, you're muted.
We'll wait for another minute and see if anyone pops up with a question.
Okay, for sure. And for anyone that needs to contact me to like ask me any type of question about these approaches and philosophies, here's my contacts on GitHub, LinkedIn, my email, and Twitter has the same handle as well, noir29@twitter.com.
And also, if people come up with questions that they want to ask the community, they can also create a thread in the community threads of HOVA, and they can ask it there, and maybe somebody will get in touch with you from that community as well. So it's good that we have an online community here.
It's especially with the HOVA polls. I've created a few of the polls, and I've noticed that a lot of the people and a lot of the participants in the poll, they had a lot of problems in that issue, in the enablement. It's like, okay, where do I start? How do I bring people together to work on like similar stuff and things like that? So that's why I focused my talk towards the data enablement and such stuff.
Yeah, that's good. We have one more minute, so I'll begin my closing. Thank you, Noir, for your presentation, and I appreciate all the attendees for the questions and interactions during this session. Please contact the speaker if you have further questions regarding this topic. Please provide your comments and feedback to us or the organizers on the community board, or start a discussion there to connect with others in the DataCon LA 2020 community. Thank you for joining today's presentation, and I hope you have gained some insights from this session. Have a wonderful day, and thank you for being a part of this year's DataCon LA.
Thanks, everyone, and thanks, Eli and Stephen, for hosting.